Our next presenter is one of the most ambitious companies in the microcap space today and has the potential of disrupting several large industries in the coming year with their technology. Heck, every industry for that matter. In my eyes, the most powerful organizations and people in the world are the ones that can take a negative and turn it into a net positive. PON Technologies, ticker POND on the TSX and PNDHF on the OTC, is literally deriving value from emissions. The company has developed a proprietary system that can profitably transform CO2 into other valuable products. Joining us to give our community an overview of what makes PON special is the Chief Executive Officer of the company, Mr. Grant Smith. Grant, thank you for joining us. I wanted to tell all the listeners that we're going to do something a little bit different today. I will be on mute, okay? But every now and then I'm gonna be a fellow potential investor because I don't own any shares at the moment, and just kind of go through side by side and ask the tough questions to Mr. Smith.
Definitely, as we agreed upon. And thanks, Chris, for having me. Great to be here.
My pleasure. Please feel free.
Sure. Well, thank you, everyone. And I'd like to welcome you all, as Chris said, to PON Technologies. And today we'll have a great discussion and overview of the company, what we've done year to date, and actually to date as a company, and where we're headed. So with that, I'll start our presentation. So again, company overview. We have three divisions that I'll highlight: PON Carbon, PON Biotech, PON Naturals. We'll touch on ownership, financials, leadership, including our board. So this is basically our perfect snapshot of the company. We're based in Markham, just a suburb of Toronto, Ontario, Canada. We've been in business for over 10 years. And during that time, we've transformed the tech to where we now have it in a very slick, I would call it a platform. And the slide here is great because it basically explains how we can take, raw stack gas, and that can be from a natural gas power plant, could be from a brewery, distillery, could be from any type of emitter. Could be from including steel and cement and heavy industry. And we can take the CO2, and it's 2 tons of CO2 grows 1 ton of algae, and that's key. So in our little model here, we show an emitter, we show CO2 goes up the stack. We literally put a hole in the stack and we capture that CO2. The CO2, think of an aquarium where you see the little bubbles coming in at the bottom. That is our photobioreactor. So we have light, water, CO2, and we take algae seed, we seed it, and over time the algae grows. The algae grows very quickly, and it's very efficiently in how it grows compared to our competitors and their various methods that we'll touch on. And the amazing part that Chris touched on is it is unbelievable where the markets for algae have now opened up. And on the pictures, we just said fish feed, pet feed, human feed, and obviously animal feed, to name a few. So we're showing an idea here of a small power plant connected to the photobioreactor system. And we can have on site in a very small footprint, 2,000 square feet, we could put a 10,000 liter PON bioreactor system, and we could abate CO2 and grow algae. So this just sort of just quickly, summarizes the tech and a bit of a demo.
Grant, I have a quick question.
Yes, sir.
So you can do this on site, meaning on location, correct?
Correct. Yeah.
The biggest question of all is how much does a photobioreactor typically cost a company to do this?
Sure.
And does it vary based off size and scope?
Absolutely. And it depends also on what type of algae you're growing. So if you're growing something that is fairly easy to grow and maybe is a lower cost per ton algae, we might use several large tanks. If we're growing something that's costly and is we don't want to waste a lot if you lose a batch or anything, we might use a wider number in terms of maybe 100 small 20 liter tanks. So everything is slightly customized, and we haven't got there yet, but we have different divisions. So we have algae for animal feed. So again, that's probably a bigger operation, but algae for COVID SARS spike 2 proteins, that's very small. And we would only need a small bioreactor. We might only need 5 of them. And that would produce hundreds of thousands of kilos per month, which is millions of dollars per month in revenue of algae on a very small platform. So again, it's very customizable depending on the emitter, what you're growing, and obviously what your end goal is.
And just this may sound dumb, which is why I'm going to ask it. The algae basically offsets the emissions. How?
So physically, to grow algae, the algae require carbon dioxide, CO2, to grow. The irony is, even if there's some NOx or SOx or anything mixed in with the CO2 that's going up the stack, the dirtier the better the algae consume, and they break it down to simple elements. So if it's a cement factory or a steel factory where it might be a little bit of a dirty sort of persona, and you may not want that for human grade algae, that might be perfect to make flip-flops or running shoes or land and soil remediation, where we put life back into the topsoil in, say, the Canadian oil sands up in Alberta, where they have a problem. They have a huge CO2 problem. They have a lot of dead land, and they need to put that land back better than when they found it. So in that case, we would tap onto that stack and we'd grow a lot of algae in, again, big tanks. And then that algae would be blended back in and put life back into the soil, and the whole cycle starts over again.
Awesome. Please continue.
Okay. Absolutely. Thank you. So this is a great slide that really highlights, the algae market as it stands today. Top left, current outdoor competitors, the current market. And I've lived this world in my former life, and I still purchase some algae from overseas. It grows in these outdoor cement ponds. Those are football fields, and I mean several. You can see how far that goes. That's a lot of water. That water in Southeast Asia, primarily mainland China, where these algae ponds are located, there are heavy metal issues in the groundwater. There are pollutants in the air. There are ducks that land in those ponds. You are relying on sunlight. When it's not sunny, you're by hand, you can see that's a high labor type, platform of growing. You're sprinkling in extra fertilizers when there's not a lot of sun. So not a very reliable, sustainable way to grow. A lot of water, a lot of labor, only grows in the top few inches. And I'll tell you from experience, we open up, the drums of spirulina, and 1 month they're olive green and the next month they're dark green. Well, if your customers are major CPGs, that doesn't work for them. They can't put out, food products that contain these algae like spirulina and chlorella that are inconsistent in color, flavor, and sometimes odor. No one wants a fishy note in their veggie burger. So that's the outdoor. The bottom left is similar, reliant on the sun, a little bit different. Those are glass tubes. So think of that as a glass tube algae farm, reliant on the sun. There are some in Israel and China, but again, a lot of energy, a lot of water, and they have to pump that algae. So there's a lot of energy used to pump that algae, and still it's quite a large footprint. So 2, daylight hours only as another one where I mentioned sunlight. The top left, this shows a very small vertical model. We took 3 containers. Inside that container, there's a laboratory, there's a bioreactor. The second floor is because we have to lift the lights out when we're cleaning or changing. But you could take that 3 container unit, Chris, you could pop that onto a small power plant in a suburb of LA, and you could start growing algae. The
Brandon,
bottom.
You mean top right, correct? Am I looking
top right? I'm looking top right. Sorry, yeah. And below that, you'll see that would be an example of we believe this is the world's largest photobioreactor. That's 22,000 liters. And you can see all the little pink, if you can see those little pink kind of circles along the top, those are LEDs, and the LEDs are submersed in the tank, and that's what grows the algae. So that actual picture is connected to a St. Mary's cement factory a couple hours outside of Toronto, where we've shown off of cement stack gas that we can grow pretty much every type of algae that we've ever grown in the lab. We've now shown that we can grow that at scale in a 22,000 liter photobioreactor off of CO2 from a cement gas factory. And they're burning plastic bags, rubber tires. I mean, they're burning bad things, and the algae still grows very, very well. And again, that would not be human grade, but that would be industrial grade algae, or like I mentioned prior.
I just have a hard time visualizing what this greenhouse, if you will, attaches to. So if I'm basically generating CO2 emissions, how do I connect what's coming out with what you built?
So great question. We literally take a 8-inch hole with an exhaust fan. We'll drill about an 8-inch hole in the side of the stack gas. So in the old days, you think of those cement stack gas that you see. So picture just drilling an 8-inch hole and putting a big pipe on there with a little exhaust fan, and we're just drawing out the CO2 and we funnel it into the tanks. So if we're using beverage grade bottled CO2, that by the way typically comes from an ethanol factory of some sort, we're using that in our lab here downstairs. We're just using that beverage grade CO2 and we're growing. But on site, we would literally put a hole and draw out exhaust and funnel it into the bottom of the tank where the water and it's bubbling in. Think of it like an aquarium.
And I got to tell you, that looks like a complicated set of machinery where you can't go on YouTube to figure out how to operate. Is there someone from your company on site at all times, or is it simple enough that someone from the other company can easily manage and maintain it?
Well, another great question. We have a team here, and we've spent $30 million in 10 years building that tech. We have 26 patents around it, so we've got a moat around that technology. Anyone using CO2, light water, and algae infringes on our patents. We also have process patents. So I'll get into it later, Chris, but there is a computer, a little bit of AI and data collection that actually helps that algae grow, almost idiot proof, where the computer now we've shown is better than the scientist. So we're there in the beginning. We help them get up and running, but once it's up and running, that algae just starts growing, and the computer dictates the pH is too high, the pH is too low. Hold the temperature at 21 degrees, or for a different strain of algae, hold the temperature at 32 degrees. So it kind of starts to grow itself. And once algae starts growing, it's pretty great. It just grows. It just really starts growing. And that's where we have another patent for what we call continuous harvest. So we're always taking a little bit off and the algae is just growing again. And once it hits a certain density, we skim it off again.
And for our listeners, Grant is Canadian, so that is Celsius, not Fahrenheit.
Correct. I married an American, so I'm good in both. But thank you.
For anyone who wants to grow some algae, 21 and 32, remember those.
Yeah, that's actually, you're right. That's the magic range. So, but most people don't want algae in their swimming pool, Chris. So we won't teach them how to grow it. So the market opportunity, this slide is fantastic in that it really sums up where we play. So food, beverage, nutraceutical. And again, this is, formulations like Beyond Meat and in that area, you're getting a growing vegetarian market. You have a huge area in natural colors. We have vegan EPA and DHA, which are heart healthy omega fatty acids that are typically from fish. We can skip the fishing stage. We can actually just grow the algae to contain the EPA. So that top market continues to grow. That's my background, where I came from. My undergrad's in human nutrition from a university just outside of Toronto. So that's how I sort of got into this space. And I've spent the majority of my career in that ingredient, CPG world. And the next area that's really growing, and we had a fantastic professor in Israel who is an expert in the aquafeed market. He said the market for fish feed is infinite. We can no longer even, farm enough land to feed fish. So we need companies like Pond Technology that can grow algae off CO2 and feed the fish, which then feeds the planet. So fish and animal feed. I'm going to touch on methane reduction by feeding cattle algae. And there are studies that are ongoing with very promising results. So that market is massive for us. And this one, we kind of stumbled across. We had a university with a Canadian oil and gas major Fortune 500 company come to us and say, we can't grow this algae at scale. We've genetically modified algae. And from that, we created a biotech industry, as we were the only company that could grow this algae that they gave us on a small little petri dish, and we grew it at scale. And the last area, and my screen is being hidden, is our bioremediation. And in our bioremediation, what we have here is that land and soil, where I mentioned that maybe it's the oil sands, maybe it's cleaning up tailings ponds at mines, where we could actually take tailings ponds, pump them into a container filled with algae, and the algae cleans the tailings ponds water and then gets put back into circulation and put back onto the land.
I'm just curious because in the last 2 years, everything has gone up in price. Is there a market for algae, and how has the price changed over the last 2 years?
The market has gone up because the majority of the algae grown in the world is in Asia. As you know, there's supply chain disruptions. Ocean freight is quadrupled. So that there's definitely a tightening. There's a supply chain. There's a shortage. But I think more importantly is that with the whole market moving to this flexitarian, meaning not that everyone's a vegetarian, but a lot of people are consuming less meat and they're looking at vegan options. There's people with allergies and so on and so forth. And they're switching to, say, coconut-based desserts over dairy, and algae fits into all those things. One of our scientists says, everybody uses algae every day. They just don't know it. It's in your toothpaste. Carrageenan is a type of algae. There's a number of ingredients within a lot of our daily products that contain algae, and we don't even know it. So these markets, Chris, continue to grow, and what they become is off takers for pond. I touched on patents just at the bottom of the screen, 26 patents, 48 global in process. So again, we've got a great patent system and we've got a nice moat around the technology. Just quick on a few partnerships. I'll touch on AB Agri, but this is our big lead partner where we've just signed an exclusive deal with AB Agri. They're a UK-based animal feed and human feed company. They're part of Associated British Foods, which is on the London Stock Exchange, $15 billion market cap, and they operate in 53 countries around the world. So I'll dive deeper into that. NRC is basically an early partner that's helped out Pond grow and fine-tune the tech. St. Mary's is our second largest shareholder. And again, they've given us the ability to use their land and put a system on their cement plant. And we've been able to show that we can reduce CO2 and grow algae. And a really great partner, we've partnered up with Malone Group out of Ireland. They've brought with them some nice contacts high up in the Irish government that have methane reduction in cattle as a real challenge. So Malone not only is our engineering partner, and they help us, construct and build the models, but they've actually been able to give us some potential inroads into the Irish government, and we're really excited about working with Malone. So here's really the highlight of the three divisions. So under Pond Technologies Holdings, Inc., we have Pond Naturals, which is really, Chris, my former business. I sold my business and merged my business with Pond because I saw challenges in supply chain before they're coming, and today we're seeing it full on. And I knew that if you don't control your supply chain, you can run into trouble, and your customers' brands and so on and so forth can be in trouble. Pond's vertical growth of growing algae was of interest to me. I had the real life challenges that I mentioned prior on, opening up a drum and it's a different color from lot to lot. And this all goes away with Pond. So my company brought in some nice revenue, brought in over 100 customers, and they're steady Eddie, repeat, pay the light type business. So we merged that. We created Pond Naturals. Pond Carbon is really the mothership. Pond Carbon holds all of the patents. This is the big CO2 platform where we can grow algae off of, stack gas. And Pond Biotech, again, I mentioned, is really growing specialized, difficult to grow algae that no one else seems to have an easy way to do it. We have an easy way to do it, but it's also very cost effective. We've kind of stumbled across this. The way we can grow it, it's a disruptive growth pattern because we're not using CHO cells or, we're not convincing the protein that it's inside a Chinese hamster ovary, which is very difficult to do. We can just grow it in algae, and we've been able to express the proteins. So I'll just dive a little deeper into each one. Obviously, the strategic goal on all three are to, grow the businesses and look for, obviously in Pond Carbon, large scale. And I mentioned Pond Biotech, little smaller scale. And then Pond Naturals is to continue selling our own astaxanthin, where we produce that right now, and also bringing on new customers and continuing to grow that nice steady Eddie organic growth business. So as I mentioned, Pond Carbon, the real goal here is to develop carbon capture projects. A lot of people are stuffing CO2 back into the ground, and I don't know what's going to happen with that. We feel that we can work with anyone that's got a source of CO2 or a way of capturing CO2, and we might be able to help them do something with that CO2 rather than just stuff it in the ground. So as we've written here, we've got the lab, we've got the backgrounds, we've got the patents to develop these processes to grow algae from CO2. The host facility gets the carbon credits. They get the green leaf that they can put on their stack. So that's a great PR campaign for any company to say, hey, we're on our way to net zero by 2050. Oh, how are we going to do that, guys? We're not the solution, but we think we're part of the solution. And then they actually get some revenue coming out the back end where they're growing algae. So we've developed this bioreactor system that gives us a tech access license fee up front. We get to get royalties on the back end. But as I mentioned during the construction, we're selling them maybe a turnkey system. So it's a vessel or a tank with lights, water, pumps, everything that's sold by Pond. It's engineered by Pond and it's serviced by Pond. And then once they're up and running, we sort of back off and then we collect the royalties. So that's our model to revenue. So it's great in the fact that, there's revenue the whole way, Chris. There's revenue up front and there's revenue in the middle, and then there's revenue coming off the back end.
So I have to be selfish here. When you talk to potential customers, they're like, well, what the hell do I get?
You as in Chris?
As in the company.
Sure. So the AB Agri deal that I'll touch on, I may as well touch on it now. It's a great example. So we negotiated with AB Agri. First, they chose algae, then they chose Pond. When they chose Pond, we said, great, we've spent years building the tech. You guys need to partner with us in some way. How about a license fee up front so you can use our tech? They said, okay, how about you give us exclusivity on animal feed and fish feed? We said, okay, we worked a deal. We got 1.5 million Great British pounds. So up in Canada, that's worth a lot of money, 1.8 on the exchange. So that's like 2.3 coming in the door. We got that money. That's in the door. Record quarter. So the license fee up front, we're selling. That's great. Now they're going to buy a photobioreactor system, in a box that I mentioned. They're going to connect that to a site that they've chosen. It's Associated British Sugar. It's a sugar factory in the UK. The plan is to take 20,000 tons of CO2 and grow 10,000 tons of algae. And then they're going to put that into all their formulations because they already have a $100 million plus business on animal feed. And here's where it gets exciting. Cattle, methane reduction, feeding them, obviously a special strain. Dairy cattle, feeding them in the water. They're producing 15% more milk. Chickens, they're growing fuller and faster. Their urine and their feces are less acidic, more healthy. Then the chicken's feet are more healthy. You're able to sell those to a market. And there is a market in Asia for chicken feet and so on and so forth. So we had one EVP fly up and say, this is a game changer. So basically AB Agri has, invested, they've spent the time, the money, the research, they chose algae, then they chose Pond. So that's really a great example of Pond Carbon in action.
Would it be safe to say that you are essentially reducing close to 100% of their CO2 emissions?
Great question. No, probably. And again, it depends on how much is going up the stack, but I would say 20, 30, 40, if someone has a really, really big ambition, we might be able to get greater than 50, but I don't think our system would reduce 100.
Okay. So that's still 20 to 25 or 30%, given that size is substantial. Yeah. So in this case, they are reducing emissions. And then they're using the algae that gets generated and they're putting it back into their products, correct?
Correct. Yeah.
So
that's a great model. Yeah. That's a great model. And I'll give you some others. Have you heard about omega-3 eggs where they feed the chickens flaxseed meal, right? So everyone has eggs. Okay.
It's the most expensive egg that you can buy here in Northern California.
Well, there'll be another one in the near future where there'll be EPA fed to the chickens from algae that'll be grown off stack gas because you know where we're going. And then we can have EPA that the layers or the hens lay eggs that are high in EPA. So, or maybe EPA and DHA, a blend. So this is where it's amazing to see the industry has sort of caught up to Pond. I think we were a little bit ahead of our time. I think we probably went public too soon. Maybe a few things we didn't do perfect, but I think we're really advancing everything. And I think the market's catching up. I think the supply chain issues, everything is we're looking at all as an opportunity.
Let's go to the Q&A because there's quite a few, and we have about 5 minutes Or
Okay.
do you want to go through the slide and
I'm
then
just
we
gonna,
can-
yeah, we touched on AB Agri. That's great. There's an unnamed Canadian oil and gas company. They were the ones that worked with us on the biotech, and we grew this COVID SARS spike 2 protein. That's great. So that's a proof of life for biotech, and there was money in the door with that again because there was a license fee up front. And this one's really neat. This is a precision agriculture, and there's a lot of discussions going on here about. I mentioned animal health, improving growth rates. I mentioned equipment and everything up front. So that one's done. Biotech, we've sort of touched on it, so I don't have to go through that. But we talked about how we can grow less expensive. It's a little better, and naturals. This is an example that's an astaxanthin tank. So we're growing this red algae that's human grade in that tank, and that's our plant. That's pond owned and operated. It's just outside of Vancouver, British Columbia, Canada. Just quickly, if you want, Chris, we have 21% inside, so fairly, tightly held, pretty good share structure. 21% is ownership, so that's management and board, and fully diluted at the bottom. You can see my screen is covered because I'm looking at your face. And just quick on financials. So record quarter for us again. We were really excited. So we had the revenue come in. They'll be a little lumpy because when we get a license fee up front, and that might be in Q1 or Q2 2022, that'll be another great quarter. But the Pond Naturals, the biotech, we have other kind of nice little deals always coming in, and sometimes we get paid on milestones. So you're always getting some revenue coming in. But I think the goal is 2022 will probably be a breakout year. We'll probably increase that revenue. We'll continue to gain on margins. And beyond there, it's looking, it's exciting. The phone is ringing. And that's something someone asked me this morning. We had another call. And they said, years ago, you guys didn't have all this in the funnel. We're like, yeah, well, right now, the phone's ringing. Companies are saying, hey, we heard about you and we have a CO2 problem and we want to grow this. We want to grow this. So I'll move over to you, Chris, for Q&A.
Awesome. First question comes from Alicia. I read in your latest financials that the pricing for nutraceuticals is $10,000 a kilo and $1 to $1,500 a kilo for feed. Are your costs of production that low?
I would say yes. The nutraceutical market is kind of set right now in algae by the Chinese. So the market is what the market is. We can probably command a premium because we'll actually have tighter specs or better specs. We'll have a better, healthier product with lower micro levels. It'll also be grown in Canada or the US to supply the Canadian and US markets. Animal feed. And again, the thing with algae is it's so diverse in its amino acid structure, its vitamin mineral contents and levels. You can add 2% of spirulina to an animal's diet and see an improvement in their growth rates, because the traditional corn, soy, and grass diet is very low, 9 to maybe 30% protein. Spirulina is 66% protein, contains the EPA, the omega fatty acids, contains all the vitamins and minerals, has a broad amino acid profile. So a small amount, 1 to 2%. So from a cost standpoint, if we hit the right cost standpoint in a formulation, it works. Livestock operators can afford it, but they're getting better results in the growth rates of the animals, especially when it comes to chickens. It's a race to see how fast they can grow them.
This is the most important question of the day. Do companies receive carbon credits for this? And if so, is there a monetary value?
Yes. The host company, the emitter, they get and keep the carbon credits. So they're the ones that are, they own the plant. It's on their balance sheet. We don't own the plant. We just make money in helping them get that plant up and running. So because they're taking the capital to build the plant, they get the benefits of the carbon credits. They get the benefits of the revenue of the algae, and they partner with Pond, and we share in that success.
And then the last question Alicia has is, does Abagri have to pay a fee per ton produced?
AB Agri? Yes, AB Agri, right? Do they pay a fee per ton? They pay a royalty to Pond, and everything is negotiated per contract. And for Pond, it's around 3 to 5% out the back end on the royalty. So yes, they would, but it's in the way of a royalty.
Don is asking, so is the revenue from the algae sale shared with the CO2 emitter?
Yes.
Yeah, that's a yeah.
Now,
So
let me add to that. There is an opportunity for Pond Naturals to be the off taker. So in certain cases, we have discussions with emitters where, someone's got a stack, it's going up the stack. We're going to take that algae, and Pond Naturals wants to grow it because we can extract that blue color and we can sell it right here, which colors, a major CPG. This is a Nestle Smarties product. So yes, Pond Naturals would then be the off taker, and we'd take that entire revenue and we'd sell that to our customers.
someone asked, what's the most interesting fact about algae that no one knows about? Because it is pretty miraculous.
There's a lot of cool things about algae. We grow a red algae in Vancouver called astaxanthin. And I'll tell you, I had investors come in this room and we would have everyone leave with a bottle of astaxanthin. And they'd come back and they say, I ran out and I need more. And we'd say, why? He said, well, when I was golfing, I didn't get a sunburn. I don't need my readers anymore. It's actually helped my eyesight. I'm sleeping better. So the antioxidant astaxanthin algae is amazing. And if you Google it and find out about it, every major supplement company sells it because it's the one unique ingredient that when you take it, you feel it. And everyone seems to get a slightly different feel. My knees don't swell anymore. I'm a former skier and hockey player. Well, still dabble, but I can't live anymore without my one pill a day of astaxanthin. So there's a unique factor in algae.
And then the final question is, have you guys kind of figured out where the inflection point is in terms of what type of business you need to do to get to break even?
Sure. I think it's a combination because we can make lower revenue but higher margin on, say, our own astaxanthin, a pond-owned plant. That's still a great story, and we continue to grow. We can expand that plant, and we can sell that astaxanthin to salmon, because salmon, if they don't get astaxanthin in their diet, they're white. They're not pink. They get it from the algae that they consume.
Interesting.
And a lot of salmon farms right now are using red dye in the feed. So this AB Agri deal pushes the astaxanthin into the feed. So, you're not eating salmon with red dye. That's part of, where we see huge opportunities. But I think the big area could be something like methane reduction in cattle, spirulina added to chickens' diets around the world. You're also the benefit, Chris, here. This is the one that really got me. And I think everybody, if you can watch Seaspiracy and Cowspiracy, if you have not watched those on Netflix, you need to watch those, because we're not the solution, but we're part of the solution. Because as I mentioned, we can skip the fishing stage. Why kill the fish to get the oil? We can grow nice, fat, customized cells full of oil, and they're vegan, which is even a benefit. But when it comes to, saving the planet, reducing CO2, and reducing arable land farming, because we can vertically grow algae that can help feed these animals that help feed the planet. So I think that's really a nice kind of summary right there.
I appreciate it. Grant, where can people go to find out more about Pond?
Well, they can give us a call. They can go on our website. We've got a lot of decks and tear sheets and information we can send out. And if they want to set up a call, like I said, my team and I are always available.
I'm telling you, in terms of disruptive companies in the small cap world, you have to be on the top of LD's list, because again, it's one of these things where it's not just one benefit, it's multi-tiered, and I feel that for the next half century, this is going to be our Manhattan Project. How are we ultimately going to reduce emissions? Because everyone kind of has a viewpoint on it, but no one will disagree that everyone wants a cleaner world with more algae.
We couldn't agree more. We're excited. We're hiring. We're growing. We're busy, and we love what we do, and we're having fun.
Grant, thank you again for your time today. I'll definitely be in touch.
Excellent. Thank you. Have a great day.
Bye-bye.